Death from tetanus infection in children and adults is very likely, and without timely treatment, its frequency reaches 70%. The most common cause of death from tetanus is arrhythmia and cardiac arrest as a result of damage to the brainstem. Mortality in tetanus is very high, second only to rabies and pneumonic plague. To reduce the mortality rate is currently not possible due to the development of complications such as pneumonia, sepsis, and cardioplasia caused by a bacterial toxin. Given the possibility of a large number of unreported cases and unexpressed forms of the disease, especially in newborns, the total annual loss from tetanus on the planet can be estimated at 350 to 400,000 people. Although tetanus does not pose an epidemiological threat, outbreaks of tetanus bacillus often occur in areas of natural or man-made disasters and military conflicts. The connection between injuries and the pathogenic mechanism of tetanus was noticed even by the doctors of the most ancient civilizations of Egypt, Greece, India, and China. Galen, Avicenna, Ambroise Paré, and many other famous doctors of antiquity and the Middle Ages also studied this disease. The symptoms of tetanus were described over 3,000 years ago in ancient Egypt. The ancient Egyptian Edwin Smith papyrus, which dates back to 1550 BC, tells of 33 cases of trauma to the skull, face, jaw, and spinal cord. Of particular interest is the case of treating an open wound on the head. From the description, the patient developed a complication that could plausibly be tetanus. The ancient physician treated the wound with an anesthetic and applied a clean bandage. He believed that the patient had every opportunity to recover. However, over time, the wound began to smell unpleasant, and the patient stopped opening his mouth due to muscle spasms. Papyrus describes the situation as follows. You will find that the flesh of this patient under the wound has become warm. He began to suffer from a toothache on the affected side. You put your hand on his face and find that his forehead is wet with sweat. The muscles of his neck are tense, his face is red. The smell that comes from his skull is similar to the smell of sheep dung. He can't open his mouth. His eyebrows are raised. His face looks like he's crying. You will say about this patient, he has a gaping wound on his head, extending to the bone and penetrating into the cavity of the skull. He has a toothache, his mouth cannot open, his neck muscles are tense. You should not treat the disease. The clinical picture of this disease was first described by the ancient Greek physician and scientist Hippocrates. Hippocrates' son, a prominent politician of those times, died of tetanus in the 5th century BC. History is silent about the circumstances of the infection and his death. That's how Hippocrates described the case of tetanus. The captain of the ship injured the index finger of his right hand with an anchor. 7 days later, a somewhat foul discharge appeared, then trouble with his tongue. He complained he could not speak properly. Tetanus was diagnosed, his jaw clenched, his teeth clenched, there was muscle tension in his neck. On the 3rd day, tone and sweating appeared. 6 days after the diagnosis was made, he died. Hippocrates was sure whoever falls ill with tetanus dies in 4 days. Whoever survives this period recovers. Over the centuries, many people have fallen victim to tetanus. There were so many of them that death from tetanus was considered commonplace. When reading the biographies of famous historical figures, one can often see tetanus as the cause of their death. James O'Brien is an Irish and American writer best known for his fantastical and surreal stories. O'Brien's story, What Was It?, of 1859, is one of the earliest representations of invisibility in fiction. It was published 22 years before Edward Page Mitchell's The Crystal Man, and 38 years before H.G. Wells' The Invisible Man. When the Civil War broke out in 1861, he joined a New York militia regiment. In February 1862, he was badly wounded in a firefight and died 2 months later of tetanus in a field hospital at the age of 35. In the 20th century, the victim of tetanus was George Alwyn Hogg, a journalist and traveler famous for saving 60 Chinese orphans from Japanese troops during the Sino-Japanese War, walking 1,100 kilometers through the mountains with them. In the 1930s, Hogg worked as a freelance journalist for the Associated Press in Japan. After the outbreak of the Sino-Japanese War, Hogg left Japan to go to China in Shanghai. There he took part in the fighting on the side of the Chinese. George Hogg wrote a book about this time, I See a New China. He founded a boarding school for 60 orphans, whom he then rescued in 1944 to 1945, taking them away from the combat zone. He adopted 4 of these children. In July 1945, while playing basketball with them, Hogg injured his leg and contracted tetanus, from which he died. Time passed, and in the relationship between people and the tetanus bacillus, practically nothing changed. People still got infected, some of them died, and physicians still could only shrug their shoulders and each time hope that the disease would pass without killing another victim. Things began to change only at the end of the 19th century. For the first time, the assumption that tetanus is an infectious disease caused by a certain microorganism was made by the Russian surgeon Nestor Monastyrsky. In 1883, he discovered the bacterium in the discharge from the wound of a tetanus patient 8 days after infection. The causative agent was isolated from the wound both intravitally and posthumously. But Monastyrsky did not manage to win the laurels of the discoverer of tetanus bacillus because he published the results of his observations with a long delay, only in 1885. Regardless of Monastyrsky, in 1884 the causative agent of tetanus was discovered by a 22-year-old German physician, Arthur Nicolaier. He is considered worldwide as the discoverer of Clostridium tetani. In England and France, this bacterium is often referred to as Nicolaier bacillus. In 1889, the Japanese physician and bacteriologist Kitasato Shibasaburo obtained the first pure culture of tetanus bacillus. Together with Emil Adolf von Behring, they demonstrated that the serum of rabbits exposed to tetanus toxin helps prevent them from getting sick. This marked the beginning of the development of passive immunization. In 1893, the French veterinarian and microbiologist Edmond Nocard successfully used serum to immunize horses passively against tetanus. Passive immunization is the introduction of antibodies to any antigens. With it, you can create only temporary immunity lasting a few weeks. Although passive immunization causes a short-term increase in resistance to the pathogen, its effect is immediate. Until the beginning of the 20th century, the disease was classified as terrible and incurable, annually claiming hundreds of thousands of lives, especially during wars. The whole subsequent history of the development of tetanus vaccines is strongly connected with the history of wars. After all, the battlefield is a place where people are constantly getting injured, and here Clostridium tetani do not miss their opportunities. The efforts of doctors and scientists were aimed at solving this problem. A couple of decades after Nocard's discovery, there was a reason for the first mass use of horse tetanus antitoxin in humans. The First World War began. Due to the fact that the drug was poorly purified, many patients developed anaphylactic reactions, that is, allergies and other serious complications. In German hospitals from August 1 to October 31, 1914, tetanus developed in 1,744 out of 27,677 wounded soldiers. The mortality rate reached 100%. Then, the use of tetanus toxoid was not routine in the armies participating in the First World War, which led to a huge incidence in the first months of hostilities. When serum supplies were normalized, this value fell to 1 case per 1,000 wounded. The observations made by physicians in that war provided an evidential basis for improving the treatment of tetanus. Speaking of passive immunization against tetanus, it should be noted that human anti-tetanus antibodies have become available since the 1960s. Today, horse serum has been abandoned in developed countries due to allergic reactions. While passive immunization introduces ready-made antibodies into the body, active immunization involves the production of protective antibodies by the body itself in response to the vaccine. To be continued in the next episode. Stay tuned.